Hello everyone, welcome back to my channel Tech Tools. In today's video, we are going to explore the Aerospace Blockset in MATLAB Simulink. This is a very powerful toolbox used for modeling, simulating aircraft, spacecraft and flight control systems. If you are an electrical, mechanical or aerospace engineering student, this toolbox is extremely useful for understanding real-world systems like aircraft motion, actuators, aerodynamics and control systems. In this video, I will explain all the major blocks and libraries step by step, how they work and why they are used, without building a full model, so you can clearly understand the concepts. So at first, what is Aerospace Blockset? So let me show you. Go to the library browser and here you can see that it is Aerospace Blockset. So what is Aerospace Blockset? So Aerospace Blockset is a library inside Simulink that provides pre-built components for aerospace simulations. Instead of building equations from scratch, you can directly use blocks for aircraft motion, aerodynamic forces, sensors and instruments and control system. So one by one we will see all the major blocks showing here. So the first block is our actuator. So double click on actuator. You can see there are two blocks inside actuator. One is linear second order actuator and another one is non-linear second order actuator. So what is actuator? So actuators are responsible for converting control systems into physical movement. For example, moving a control surface like an elevator, rotating a motor shaft. Then we have our aerodynamics block. So here you can see there are two blocks. First one is aerodynamics, aerodynamic forces and movements, digital datcom forces and movements. So what is aerodynamic block? So this block calculates forces acting on the aircraft due to air, such as lift, drag, side forces. Then we have animation. In animation, the first block is animation support utilities. So here you can see that pilot joystick, all simulation pace. There are three blocks. Then we have flight simulator interfaces. Here you can see there are several blocks like flight gear pre-configured, 6 DOF animation, generate transcript, and etc. You can see that one by one. Then we have MATLAB based animation. Here we have 3 DOF animations, 6 DOF animation, MATLAB animation. Then we have Simulink 3D. In Simulink 3D, by the help of Simulink 3D, we can make a aircraft in a 3D model. So what does animation work? Animation blocks are used to visualize the motion of aircraft. Instead of just graphs, you can see aircraft movement in 3D, orientation changes. This makes your simulation more interactive and easier to understand, especially for presentations and videos. Then we have our next block, environment. In environment, we have atmosphere, celestial phenomena, gravity and wind. In atmosphere, we have different blocks like CIR 86 atmosphere model, CUESA atmosphere model, ISA atmosphere model, and the others. You can see them one by one. Then we have celestial phenomena. In here we have delta UTI, Earth nutation, Earth orientation parameters, moon libration, and the others. Then we have gravity. In gravity there are several blocks also. You can see them one by one. Then we have wind. In wind there is a discrete wind gust model and the other blocks also. Then we have equation of motion. In equation of motion, with the first block we have 3 DOF. So what is equation of motion? So this is the core of any aerospace system. Equations of motion blocks calculate how the aircraft moves based on forces and movements. They use Newton's law, force equals mass times acceleration, movement affects rotation, This block determines position, velocity, and orientation. Without this, simulation is not possible. So here you can see that 3D wave body axis, 3D wave wind axis, custom variable mass, 3D wave body axis. There are 6 blocks. Then we have 6D wave blocks. In 6D wave, there are many blocks also. So you can see them by pausing the video. Like first one is 6D wave Euler angles, 6D wave Euler angles, then 6D wave quaternion, then we have 6D wave ECEF quaternion, and the others. Then we have point mass block. In point mass block, we have fourth order point mass forces, fourth order point mass, and the other blocks. Then we have flight instruments. Here you can see airspeed indicator, altimeter, aircraft altimeter, artificial horizon, EGT indicator, climb rate indicator, heading indicator, RPM indicator, turn coordinator. Actually, this one is a special block. Then we have flight parameters. In flight parameters, we have dynamic pressure, ideal airspeed correction, incidence and airspeed, incidence, side slip and airspeed, and the others. Then we have GNC. In GNC, we have control, guidance, and navigation. So what is GNC actually? So GNC stands for guidance, navigation, and control. These blocks are used for path planning, stabilization, and autopilot systems. This is where control engineering concepts like PID controller are applied. I will teach you the PID controller in upcoming videos, so stay tuned. So in GNC, we have mass properties like estimate center of gravity, estimate inertia tension, estimate inertia tensor, moments about CG due to forces, symmetric inertia tensor. Then we have pilot models, crossover pilot model, precision pilot model, touchscreen pilot model. Then we have propulsion. Here we have multi-rotor, rotor, and turbofan engine system. Then for spacecraft, we have CubeSat vehicles and spacecraft dynamics. So in CubeSat vehicles, we have CubeSat vehicle, custom pointing, CubeSat vehicle, nadir pointing, CubeSat vehicle, sun tracking. Then we have spacecraft dynamics. Here we have attitude dynamics, attitude profile, geographic pointing, attitude profile, nadir pointing, attitude profile, sun tracking. We will use these blocks in upcoming videos where I will teach you how to simulate and design a model using these blocks. Then utilities. Here we have axis transformation, math operations, and unit conversions. Double on axis transformations. So here you can see that there are several blocks in here. You can see them by pausing the video. Then we have math operations. There are several blocks also. 3x3 cross product, adjoint of 3x3 matrix, create 3x3 matrix, determinant of 3x3 matrix, invert of 3x3 matrix, and the others. Then we have unit conversions, acceleration conversion, angle conversion, angular acceleration conversion, and the others, and many more. So this was a complete overview of Aerospace Blockset in Simulink. In the next video, I will show how to build a complete aircraft model using these blocks step by step. If you found this video helpful, don't forget to like, share, and subscribe to Tech Tools. Thank you for watching.